All right, ladies and gentlemen, we're going to look at what we call rationalizing the denominator. This is something super important because, like there are rules with algebra, and one of the rules is that we cannot have a radical in the denominator. So what we need to do is simplify as far as we can. In this case, we'll look at some examples, and then we'll go from there. So let's see what we have here. So for our first example, we have the square root of 20 over the square root of 60. So what we're going to want to do is stretch both of these out, which would be 2 times 2 times 5. And then in the denominator, we would have 2 times 2 times 3 times 5. So in this case, we're able to cancel these 2's and the 5. So that means I'm only left with the square root of 3 in the denominator. So I have 1 over the square root of 3. So let's look at how we're going to rationalize this. 3. Sorry, just making sure. So when you multiply a fraction by 1, it does not change its value. Any expression divided by itself is equal to 1. So for example, 2 over 2, square root of 2 over the square root of 2, these all have a value of 1. So to get rid of a radical in the denominator, multiply the numerator and the denominator by the radical, in the denominator. So you're basically going to create a value of 1 using that radical. So let's look at the one we just did. We got down to 1 over the square root of 3. So what we're going to do is multiply times 1 by using the square root of 3. So 1 times the square root of 3 is square root of 3. Down here now we have the square root of 9. So what we essentially just did there was create a perfect square. So in the numerator now I have the square root of 3, and in the denominator I have just 3. Because remember, this is 3 times 3. Now we have rationalized our denominator in order to eliminate any radicals in the denominator. Let's try some more. So in this case, I can't simplify. There's nothing to multiply. So what I'm going to do is multiply times 1 by using that radical of the square root of 5. So as I multiply across, I end up with 11 times the square root of 5 over the square root of 25. So then I have 11 times the square root of 5 over 5. Now I want to look at 11 and 5. I cannot simplify that as a fraction, so then this would be as far as we can go. All right, here's another one. Moving along. So I'm going to multiply again. Let me change the... I'm going to multiply times the radical only that's in that denominator. So square root of 3 over the square root of 3. So as I multiply, I end up now with the square root of 6, because remember they have the same index, so I can multiply those. Then I have 3 times the square root of 9. So square root of 6, can't do much with that. Down here, though, this has a value of 3, so then I end up with 3 times 3. So we have the square root of 6 over 9. Some of you may want to simplify, but remember that 6 is under a radical while the 9 is not. So then we would stop there. All right, here's another one. going to multiply times 1, so square root of 2 over square root of 2. So this would be 6 times the square root of 6 over the square root of 4. 6 times the square root of 6 over 2, because the square root of 4 is 2 times 2. Now if you notice here, I can actually simplify this like a fraction. So if I have 6 over 2, that actually gives me 3 over 1. So when I go to simplify this, this would be 3 times the square root of 6. And technically, I could put it over 1, but I do not need to. So then this is as far as we can go. All right, last one. Now, this one's a little more challenging because we have to divide first. So I'm going to stretch this out. So this would be 3 times 5. Then in the denominator, 6 times, let's see, 2 times 3 times 5, 6 times 5, nope, sorry, got it carried away there. 2 times 3 times 3. So first of all, I'm going to cancel and simplify wherever I can. So first of all, I'm going to look outside that radical. Notice these are both divisible by 3. So this will become a 1, this will become a 2. Then under the radical, I can actually eliminate a pair of 3's. So when I simplify this, I end up with the square root of 5 in the numerator, and then 2 times the square root of 6 in the denominator. Now I'm going to multiply times 1. So times square root of 6 times the square root of 6. I'm running out of room, so I'm going to kind of shift down this way. So now I have the square root of 30 in the numerator, and the denominator I have 2 times the square root of 36. Square root of 30 stays up top. In the denominator now I have 2 times 6. So square root of 30 over 12.